So let's say you have the T distribution here. Say this is T of minor or normal distribution here. Right, since this T has more spread, the T star is going to be bigger than the Z star. If you want to get an area of 1 plus C over 2 to the left of this number, you have to go out farther for the T distribution.
Wouldn't it be 1.24? So 1.214?
So I got 1.214. And the people agree with 1.24? No, I can double check after class. So yeah, like mathematically, or maybe computationally, this T has more spread, so that's one reason. But thinking more conceptually, no, the conceptual reason for why you get wider confidence intervals with T is because we're missing some information, right? If we're missing some info, we can't make as good predictions. Right, and so that means if we're missing sigma, we get a crappier confidence interval. We get a wider one that tells us less information. So that's conceptually why I'd expect to get wider confidence intervals with T than normal distribution. On that note, let's also talk about these margins of error. So I must focus on the case where sigma is known, but really it works in both cases. So if sigma is known, then the margin of error is equal to that Z star times sigma over square root of n. And so let's think about what we can do to get bigger or smaller confidence intervals. Okay, so again, we can think of this computationally versus conceptually. So, computationally, if sigma goes up, so if we're making this number here in the numerator get bigger, this whole margin of error also gets bigger. So if sigma goes up, margin of error goes up. Okay. What about if the confidence level goes up? So if C goes up, how does that affect this margin of error?
It's larger.
What's that?
Gets larger.
It gets larger. Why does it get larger?
Because we're more certain that our
right. We want to be more confident, and to be more confident in what we're saying, we have to say something less specific, basically. That's the conceptual reason. If you want the computational answer, right? If you look at our normal distribution, Here's our z star. This area to the left is 1 plus c over 2. If c goes up, that means we have more area to the left, and so this z star gets pushed out farther to the right. So if c goes up, then z star also goes up. And that means the margin of error goes up as well. Right? Z star is here to the left. If this number is really big, so is this product. Okay? Finally, if n goes up, then the margin of error goes down, because this n is in the denominator. So if we're dividing by a really big number, we get a really small number at the end of the day. Okay. So those are the computational explanations. And again, well, so what were the conceptual explanations here? Right, so the idea is we get a narrower margin of error, we get a smaller margin of error if we are more sure of what we're saying, basically. If we're able to make a better prediction, we get a smaller margin of error. And so what gives us better predictions? Well, if the population doesn't vary so much, it's easier to predict what it's going to do. So that tells us if sigma is small, we get a smaller margin of error. Similarly, if we get a lot of data, we can make a better prediction. So if n is really big, our margin of error should be small. And finally, if we want to say something that's 99% likely to be true, it's going to be a more vague statement than if we just want to be 80% true. It's like I can tell you there's an 80% chance my cat is sleeping on my couch right now, but I'm not 100% sure of that, right? If you want me to be 99% sure, I'll tell you he's somewhere in my apartment. If you want to be 99.9% sure, I'll say he's somewhere in Salt Lake City, right? The more I don't know 100% surely that he's going to be in my apartment. That's sort of the conceptual reasoning behind that. So,
I've got a question about confidence. I understand how the margin of error can go up if this is just like an area out of 1 and confidence is also going up.
So could you repeat your question?
So if this entire thing is like an area of 1 and our confidence is going up, how can the margin of error also go up?
So the margin of error can be super big, right? Margin of error is basically saying, what part of a number line do you think mu is going to be? So that could be a really big interval or a really small interval. So this margin of error can be way bigger than 1. This C has to be smaller than 1, but you can still, if I give you C at 0.9, you can still raise it to 0.99 or 0.999. Does that answer your question? Okay, so let's really quickly talk about hypothesis testing.